Happy Friday! Thanks so much for tuning in to N-TECH-KNO with Lissa. Today I'm going to take on a very intimidating, very large topic called machine learning. I did a poll on LinkedIn and folks overwhelmingly wanted to know more about machine learning. Hopefully today I can provide an overview that is useful to a business leader or useful to a technology leader hoping to explain machine learning in a simple, easily digestible way for a business leader. So machine learning is very complex, and for ease of presenting today, I have pre-whiteboarded everything, which I will post in the comment section under the video after I get it up. You're welcome to comment and correct me because, as I said, I'm not going to be the most technical person in the room, but hopefully this is useful just from a general understanding of machine learning. So in order to break it down, we're going to talk first about traditional data usage. So traditionally with data, what we do is we put data into a computer, we apply rules to that data, and that data then creates an output. In a machine learning scenario, we take the output from traditional data, we add more data to it, and then the computer makes a prediction, which we then apply rules to make the prediction more usable. So the goal is not to have the prediction be 100% correct 100% of the time. It's for the prediction to be accurate enough to use the prediction or make it useful. So all of us are exposed to machine learning every single day. One example is social media. So if you're on social media and you have been Googling, let's say hiking boots, and you realize that on Facebook, it's recommending that you buy a hiking pack or a camelback, for example, that Facebook algorithm has said to it, based on what your email has searched, this person might be interested. It's predicting that you might also be interested in things outside of hiking boots that have to do with hiking. So I'll talk more about how they do that later. Another example, if you're not on social, is if you fill out a healthcare form, that healthcare form is generally making predictions about your health. Let's use insurance as an example. If you have pre-existing conditions, if you don't, or if you smoke or you don't, it's making predictions about your health long term. So it's deciding, the rules are deciding or making a prediction about how insurable you actually are. So we're all exposed to it every single day, whether we realize it or not. Now, for ease of presentation, I'm going to talk about 3 ways that machine learning is configured. So there's supervised, unsupervised, and reinforcement machine learning. Supervised machine learning is where we, as the end user, give the computer labeled data. So we tell the computer ahead of time, this is a picture of a dog, this is a picture of a cat. So when we put in the picture of the dog, we ask the computer, the algorithm, we're asking it, hey, is this a picture of a dog? Well, it knows what a dog looks like, and then it sees the cat and it knows what a cat looks like, and it says, nope, these two don't match. That's supervised data. Unsupervised machine learning is when we do not label the data. So we give it pictures of dogs and we give it pictures of cats, and when it sees a dog and it compares a cat, it's like, these two don't match, and it gets another dog and it's like, oh, these two dogs look like, so I think that these are both pictures of dogs. I think that these are both pictures of cats, and that's how it's making the prediction. And you need more data for unsupervised machine learning. Reinforcement machine learning is generally very accurate or more accurate because we, the end user, have to tell the computer that yes, it's right, or no, it's wrong. No, it's wrong. So if we give it a picture of a dog and it says, yes, this is a picture of a dog, we say, you're right. And then it learns. And then we give it a picture of a cat and it says, yes, it's a dog. We say, no, you're wrong. And it learns. And so the more data that you have in any of these scenarios, the more accurate the prediction will be. I say it all the time. Data is our most valuable asset. So in any type of business situation, using machine learning can shave valuable time off your marketing efforts, off of your service efforts, any type of way to serve a customer. This streamlines the way that we do that, and it makes, if the algorithm is set correctly, then hopefully the prediction is mostly correct, and so it should drive revenue in your business. So I'm going to talk a little bit about how the algorithms work and the steps that you take to set up a machine learning environment. Bear with me as I change my board around. Normally I just flip the board, but I did it wrong this time, so I had to like spin the board around. It's very exciting stuff. Leave you all in suspense. Let me get it to where you can see it. There we go. Okay, so how the algorithms actually work. This is a super simplified version of how the algorithms actually work. Let me grab my marker here. Okay, so let's say that we want to sell Sally a shirt. That's Sally, and we're basing our prediction or our algorithm on whether the shirt is casual or formal, cheap or expensive. And we plot all the data points based on what Sally has done. So this is a supervised machine learning environment, and all of the dots up here are where she has most often purchased a shirt, okay? And so we know that based on the model that Sally likes shirts that are moderately formal or fairly formal and more expensive, on the more expensive end. And so where machine learning comes in is, what if we're going to take our shirt that we have that is middle of the road expensive, middle of the road formal. We're going to plot that data. And what the algorithm does is it draws a circle. This is very, very simplified, but it draws a circle around that new data point. And then it says, well, in this area of the data, she's more likely to purchase than she isn't to purchase. In other words, there are more purchases in the circle than non-purchases. So it says it's going to make the prediction that yes, Sally will buy this shirt. And the hope is that it's fairly accurate. If it's not accurate, we'll change the algorithm, we'll provide feedback to the data, apply rules to the data, and then hopefully the prediction will become more accurate. So that's kind of how it works. Now, when you're setting up a machine learning environment, generally what you do is you define the question. Will Sally wear this shirt? Then you collect the data. So you plot all of the shirts that Sally has purchased based on the requirements on the graph. Then you visualize the data, which is what I drew out here. Then you test the algorithm. So you plot the shirt that you want her to buy, and you say, yes, she'll buy it, or no, she won't. You predict that she'll buy it. Did she buy it? Yes or no? If she bought it, if she was going to buy it, yes or no, you were testing the algorithm. Then you're going to collect the feedback. Did she buy it? Yes or no? And then you essentially refine the algorithm. So she only bought it 50% of the time. We know that we have to refine the algorithm so that it's more accurate. Then you essentially loop stages 1 through 7 for any of the data that you want to collect. And then you use the model to make predictions. So that is my super high level, super basic overview of what machine learning is. Hopefully you found that useful. Hopefully I didn't put my foot in my mouth more than once, but please drop a comment, subscribe to my channel, N-TECH-KNO with Lissa, and thank you so much for watching.